Okay, so this will be our last algebra lesson for the week. I want to talk about a little bit of what we did a couple of days ago, and then it'll tie in with the video that you watched yesterday. So the topic is called continuous interest. And I had mentioned how sort of a basic interest type problem, whether it's for a loan or an investment, is the kind of thing you could or should have covered in 7th or 8th grade, or maybe even earlier than that. And that was called simple interest. And that formula was interest equals PRT, and then you can find the total amount by adding the interest plus the principal. So principal rate time. And so an analogy for that is you've got your principal, which is like the amount of money you borrow or the amount of money you invest when you first start. And then there is the amount at the end, because when you borrow money, you always pay back more than you borrowed. Or if you invest, hopefully you get more money than you invested. So like if the principal is the first floor, the total amount's the second floor. With simple interest, it just takes one giant step to get there. One calculation, and then that's it. Whereas compound interest, a much more complicated formula, and it's just A. A equals P times 1 plus R over N to the NT. That's like getting from the first floor, the principal, to the second floor, the amount, in multiple steps. And gosh, those steps look awful, but whatever. And then there's different scenarios. So like 4 steps would be an example of quarterly interest, like every 3 months. 12 steps, monthly interest. 52 steps, weekly interest. 365 steps, daily interest. And so that's compound interest. And we did a worksheet on that. So today we're going to talk about continuous interest. And that's like get it from going from the first floor, which is the principal, to the second floor, which is the total amount. You're taking a ramp. So I did a curved ramp because if you think about how those exponential graphs look, they're always curved. So maybe more like a skateboard or BMX type ramp. But the idea is it's a smooth transition. There's no individual little steps that get you up there. It's just one smooth ride. So that's kind of the analogy of continuous interest. The formula for continuous interest is right here. Starts off like the other one, A equals P, but then it has times e to the RT power. So A is still the amount, P is still the principal, R is the interest rate. That's the one with the percent sign on it. That's the one where you have to move the decimal 2 places over. T is time, still in years, but now E is Euler's number. 2.71828 and on and on and on. So that number is a critical component of this calculation, just like pi is a critical component of various circle formulas and things like that. So E, even though it seems like this random collection of digits that go together to make a number that who really cares about, it's kind of a fundamental number that really applies to certain scenarios. Now we're just looking at the financial, but you can take biological growth, populations, bacteria, even the virus thing we're going through right now, and there's a similar equation that models that type of growth. It also applies to physics, like radiation, or what is it, half-life and decay. There's all sorts of applications of this. We're just focusing on the financial today, but this E number is really significant. And over here I just wrote the comparison to the compound interest formula. So basically, it's kind of the same formula, but n is infinity. You can look at a ramp as steps where there's infinitely many steps. There's so many steps that in between them you can't tell any difference, so it's just a smooth ramp. So this is the formula that we're going to be working with on the exercises down below. As normal, I'll do the evens and I'll sign the odds and just give you a little preview here. Not a lengthy assignment. Word problems, yes. 4 problems for a Friday, not that bad. Okay, Stefan wants to invest $5,471 in a retirement account with a fixed annual interest rate of 9% compounded continuously. So when you see that word, that's telling us that we're going to be using this formula, A equals PE to the RT. What will the account balance be in 17 years? So if you're earning 9% interest for 17 years, you would expect this amount to go up. So let's see what the actual amount is. A equals 5,471 multiplied by E to the power 0.09 times 17. That's what we need to essentially just type into the calculator. Now, let me talk about showing work, because this has come up with various people when I'm grading homework and turning it back and stuff. I know that a problem like this, you're not doing work. The calculator's doing the work. There's no steps. You're not solving anything. So don't expect to see a lot on a problem like number 2, number 4. The actual writing on your part is very minimal. But when we get down a little lower to the other problems, you'll see what I mean when I say show your work. So anyway, 5,471. Now I need E. It would be nice if there was sort of an E shortcut button somewhere, but if it's there, I certainly haven't found it. So what I do is I hit the ABC button. You see the bottom left corner down there? Just use the letter E, go back, hit the power button, and then parenthesis 0.09 times 17. And there's our answer, 25266.0. Now, where do we round off? We're dealing with money. Money is 2 decimal places, right? Cents, pennies. So 0.0453948. Rules of rounding, that 4 would round up to a 5 because of the next digit. So we're looking at $25,266.05. So that is pretty substantial return on an investment. Okay, next problem. Eduardo invests $3,902. Interest rate is 4%. Continuously, again, that tells us that we're going to use this particular formula as opposed to any of the other formulas. 19 years, of course, is the time. So here's our principal, here's our rate. Amount equals $3,902 times E to the 0.04 times 19 power. 3902. ABC button, the letter E, power button, parenthesis 0.04. Oops, that was a mistake. Parenthesis 0.04 times 19. And we get 8,300, oops, comma's in the wrong spot, $8,343.55. Stick a $sign on there, and done. All right, let me check 2 and 4, make sure I didn't make any mistakes. So we're looking for $25,000 and some change, $8,000 and some change. So 25,000, 8,050, yep, rounded off right and everything. So E is that number you learned about yesterday. It's part of this formula for what we call continuous interest, so that at any given moment, interest is being calculated and added into a loan or an investment. This is the key formula. So now let's talk about the next 2 problems. Shanice invests $8,007. That sounds like a principal amount in a retirement account with a rate of 6%. That sounds like our R. How long will it take? So how long means that T, time, is an unknown, to reach an account balance of 18,000 blah blah blah. So that's our final amount. So 18,547.15 goes on the left side of the equal sign. $8,007 is our P on the right side times E to the 0.06 times T power. So we need to solve for T. This is an exponential equation, and as we have learned, to solve an exponential equation, we will be using a logarithm. But not yet. Our first step will be dividing both sides by 8,007 to cancel this out. We get E to the 0.06 T over here. The other side of the equal sign, we'll calculate 547.15. So 2.3164 if I'm rounding off correctly. And I'm going to move this equal sign over so I have room there for my logarithm. Okay, so we did the first step, dividing to cancel out that $8,007. Assuming I typed everything in the calculator ready, we're now ready to do what it takes to cancel out E. So the idea would be take log e of both sides, because the base of the log has to match the base that you're trying to cancel out. So if I go to my functions, miscellaneous, and I choose log a, oops, I don't want to do that there. Let's get rid of that. Functions, log a. Down here I need e, so I can go to the alphabet. I can stick the letter e there. And then in here, 2.3164, I get 0.84, well, so 0.84. Now I'm not going to, I am going to finish the problem, but I want to take a time out for a second. As we have said in the video, and I've tried to make a point now, e is kind of an important number. It has these weird important properties and applications, just the way pi does in geometry, e does in algebra and calculus and all sorts of stuff. So that being the case, calculator manufacturers have decided to make a specific logarithm button just for e, and that's this ln button that I briefly mentioned quite a while ago but didn't go into any detail. So ln stands for natural log. The natural log is the same thing as log base e. So if I type in 2.3164, I get the exact same answer as what I did previously, but I only had to hit one button. I didn't have to go through the ABC menu and do a lot of extra stuff. So virtually every scientific calculator has an ln button. It stands for the natural log. It's just a shortcut. So if I go back to this work here, I can just take ln of both sides. Now I write ln in cursive because when I print it, my L looks kind of like a 1, and math can be confusing enough. You don't need my handwriting to make things worse. So I use ln for natural log. So you can do ln of both sides. Just know that ln cancels e. Maybe repeat that over and over. ln cancels e, ln cancels e. That's what you need to know. ln cancels out e. It's called the natural log. I think the mathematician who really established the natural logarithm chose to name it in Latin because that was the thing when you're writing books, scientific and important works back in that era. So it was like logarithm naturale or something. That's why it's ln and not nl. But we call it the natural logarithm. ln, it's like a shortcut button on your calculator. Okay, so hopefully that's beat to death and you get it. To finish this problem, I need to now divide both sides by 0.06. That cancels out. So if I start a new line, 0.84 divided by 0.06, nope, 0.06, we get 14, exactly 14 years. So that's our answer to this. Now, as you can see, I could not just type something in the calculator, get the answer. I had to do some work. I had to do some algebra. I showed steps. I showed how ln cancels out e. I'm not saying your work has to exactly mimic my work. You don't have to do every single step exactly how I do it. But if you're just writing 14 years down, you're not showing the work that needs to be shown to get credit. And you will be asked to do this assignment again. So keep that in mind. Number 6 and 8 are going to be like 5 and 7 for you. You're going to have to show your work. All right, let's do 8 and wrap this up. So Carlos invests. This is our principal amount. In a retirement account, fixed rate of 5%. That's our R. How long will it take? How long is time? That's our unknown. To reach 9,000, etc., etc., that's our final amount. So 9,363.95 equals $4,650 times e to the 0.05 times t. I guess I don't really need the parentheses there because I'm not typing that into a calculator. So there is our equation. Step 1, divide both sides by 4650. These cancel out. 9363.95 divided by 4650. 2.0138, I guess is how that's going to round off. Let me leave a space there, 0.05t. The reason I leave a space is because to cancel e, I need to use a natural log. Then I do the natural log of the other side as well. Function ln 2.0138 0.0138, 0.7000. So yeah, that's good enough. If this cancels out, I get 0.05t equals 0.7. Divide both sides by 0.05. So 0.7 divided by 0.05, 14. What the hey? Okay, so a lot of originality here. This one also takes 14 years. Let me check 6 and 8 to see that I did those right. Oops, scroll down too far. 14 years, 14 years. So look at the ones you're going to do. They're not 14 years. Don't assume just because mine were, then, whatever. Okay, so hopefully you see what your work is supposed to look like, or at least close to it. You understand that this is a new concept, the idea that interest is calculated in sort of a continuous flow instead of step by step, and that this is the formula that goes with it. The two types of problems are plugging in the numbers and just getting the answer in a calculator, or calculating time where you have to do some algebraic steps before you can get the final answer. All right, as usual, if you have questions, post them or email me, and get this done. Good luck, and then hopefully have a good weekend. Bye-bye.